In the previous lesson, we talked about declarative security provided by Java EE application servers. It's great compared to writing security code ourselves, but not so great when it comes to security features and capabilities. So what exactly do we need for web application security? Well, we'll need authentication, that's for sure. As for authorization, we'll need URL-based authorization. For example, we would want to say only administrators can access any URL that starts with /admin/, something like this. And we may also need method level or object level access control. For example, we might want to say only administrators can call the method createUser, for example. And we may also want to say for a regular user, they can only access their own user object, but not a user object representing a different user. And when it comes to view, we should be able to hide or display certain view elements based on some security constraints. For example, in a JSP, we should be able to say, if a user is an administrator, show the create user button, otherwise hide the button. In this lesson, we'll introduce Spring Security, which is a Spring-based security framework that addresses all these requirements of web application security. But before we learn how to use Spring Security, it's important to understand how Spring Security works. Spring Security relies on three things provided by Java EE and Spring: the ability to intercept HTTP requests and responses, the ability to intercept method calls, and the ability to modify views. We are quite familiar with customizing JSPs with custom tags, for example, using if tag to display or hide certain part of a JSP. So we'll focus on the first two, intercepting requests and responses, and intercepting method calls. We know servlets and JSP very well, which are two components of Java EE. Filter is another Java EE component that you probably haven't used a lot before. It's quite useful in certain situations though. As shown in this figure, a filter allows you to capture HTTP requests before they get to a servlet or JSP, and capture HTTP responses after they are generated by a servlet or JSP. Now let's see a filter example. Let's run this project. Okay, so in this project, under the filtered folder, I have a JSP called add.jsp. It's a very simple JSP, and it looks for two variables, A and B, and try to display the sum of A and B. Now, if we go to the JSP, which is here, if we click on it, it shows nothing plus nothing is 0. And that basically means there's no variable A and no variable B, and the sum of nothing and nothing is 0 in expression language. Now, of course, we can set, for example, request variable A and request variable B in a controller or in this JSP directly and so on. But let's say we want to do something fancier. We want to set those two variables in a filter. So a filter will look something like this. So very similar to Servlet, a filter has to, well, actually it's not quite similar to Servlet. For Servlet, we have to inherit from a superclass. HTTP servlet, but for a filter, we just need to implement a filter interface. A filter interface has three methods: init, destroy, and do filter. So these three methods are kind of similar to init method in Servlet, destroy method in Servlet, and do get and do post in Servlet. Init and destroy, as the name suggests, you can put in some code to be executed during initialization and during the unloading of this object, and we don't need to do anything for those two methods. In do filter, which is kind of like do get and do post in Servlet, this is where we put the code that actually does the processing. Notice that this do filter method has access to request, access to response, as well as something called a filter chain. If you look at this figure, you can see that this allows the filter to process the request, process the response, and also forward the request to the servlet or JSP or whatever that is next in line of this filter. So inside the do filter, what we are doing is we are setting two request scope attributes, A and B, and A is 10, B is 20, and this part of the code corresponds to this part in the figure. So this is what we do when we capture the request, and we can do something with the request. And then how do we forward the request to whatever that is next in line? Well, this is this statement. So this statement will, when we say chain do filter and pass on request and response, we are passing on those requests and response to whatever that is next in line. And once this do filter method returns, the control gets to here, which means that all the other servlets, JSPs, or other filters have processed the request and response, and now the control is returned back to this filter again. And at this point, we can do something with the response. And here, I'm just setting the content type of the response to text. So this is what a filter looks like. And then we need to change web.xml a little bit so that this filter can be applied to some servlets or JSP. And here, again, very similar to specifying a servlet, we first specify a filter, give it a name, and specify the filter class, which is this one. And then we, again, like mapping the URL patterns to a servlet, we map URL patterns to a filter. And notice that this add.jsp is under /filtered/. So what we can do is we can say /filtered star filtered star. And what this URL pattern means is that any request that starts with /filtered/ will have to go through this filter. So other requests don't have to go through this filter, only the ones that match this URL pattern. Okay, so let's run this again. And if we click add again, notice that first, now we see 10 plus 20 is 30. And secondly, notice that the browser now displays the response as a text file instead of as HTML. So we now see all the tags directly. So this is how we can create and use a servlet filter provided by Java EE. And the Spring has something very similar to filters called handler interceptors. By the way, Spring has two types of interceptors. One is called handler interceptors, and the other one is called method interceptors. Method interceptors, if you remember, we discussed those when we talked about aspect-oriented programming. And the handler interceptors are interceptors that work like Spring filters, and just like not Spring filters, sorry, Servlet filters. They do exactly the same thing as the Servlet filters, which is to intercept HTTP requests and responses. The only difference is that the Spring handler interceptors are Spring beans, so they support dependency injection and such. So where are we going with this? Well, remember that we are talking about security, right? And here are the things we want to do. If I ask you to implement a security framework like Spring Security, and I tell you that you have the ability to intercept requests and responses, which requirements here can you address by taking advantage of this ability? In other words, what security-related things can we do here if we intercept this request? And what security-related things we can do here if we intercept this response? Well, here we can actually do quite a lot. In particular, we can check if the user has already logged in. And if the user hasn't logged in yet, we can redirect the user to login page. And most importantly, we can check if the user can access the URL, right? Because when we have access to request, we can do request get session, which means that we can check if there's already a session attribute set representing whether the user has logged in or not. If not, we can do a redirect, and actually redirect is here. Actually, no, redirect should be here before the response is created. Okay. So the important thing is to understand that when we have access to request, we can do quite a lot with it. As I mentioned, we can go from request to session to check whether the user has logged in, and we can redirect the user to a login page if the user hasn't logged in, and because we also can access the URI from request, we can then check if the user can access that particular URL, or in other words, we can implement URL authorization here. So, and that's this part. So as you can see, the ability to intercept requests and response is quite useful when it comes to security, and we can do quite a lot here. Now, on the other hand, there's probably not much we can do here, because at this point, the response is already generated by the controller or the JSP or whatever in between. And so we can do something like setting certain response headers and so on. But right now, I cannot think of anything security related that we can do at this point. If you can think of something, let me know. Well, there are still other things we need to do, but remember that we have another trick up our sleeves, and that's intercepting method calls. By the way, again, if you remember, the ability to intercepting method calls is provided by Spring's aspect-oriented programming support, which we discussed a few lessons back. So here again, the question is, what can we do here in terms of security, and what can we do here in terms of security? So here, notice that at this point, we know who the user is. Again, we know if the user is logged in, and again, we can do redirect, or well, at this point, we can no longer do redirect, but we can deny access and so on. So here we can still check if the user has logged in, and we at this point also have access to all the information about the method in terms of the method name, arguments, return value type, and so on. So here we can check if the user can access the method, or in other words, we can implement method authorization here. And what about after the method is executed? Well, here we know everything as before, but in addition to that, here we also have the return value of the method. So here we can check if the user should be allowed to access this return value, or in other words, this allows us to do object authorization, and object here meaning the return value of this method. So as we can see, with the ability to intercept requests and response and methods, in theory, we can implement our own security framework if we want. And once we understand this, it's a lot easier to learn how to use Spring Security. Okay, so now let's add Spring Security to our CS jobs project. Let me stop this, close this, and we're going to add the dependencies to CS jobs. Let me also go to the Spring Hibernate from scratch example. The network is very slow. Well, let's try if we can just add it here directly. It's called Spring Security Config. Spring Security Config. And it's this one. And the other one is Spring Security Tag Libs. Spring Security Tag Libs. And it's this one. Okay, so now we have added the dependencies to our project. And the next step is to change the web.xml file a little bit. Okay. So what we are doing here is we have added a Spring Security filter, and notice that the URL pattern for this filter is /star, which means all requests will pass through this filter. This is important because We don't want to miss anything when it comes to security. And now let's talk about how to perform authentication using Spring Security. We'll cover 4 subjects here: login and logout, authentication against a database, accessing principal, or in other words, the current user in application code, and implementing our own user service, which is the code that authenticates a user. So first, we want to add this tag to application context.xml. And so this is basically this part, and we need to modify the application context file here. And the HTTP tag and tags like authentication manager, authentication provider, and so on are all under the security namespace. So we need to first add the namespace to the configuration file. Okay, and then let's add the security stuff. Let's start with this one first. Okay, so there's a tag in the security namespace that's called HTTP, and there's an auto-config attribute. We set it to true. What does this mean? This does several things. It's equivalent to using the HTTP tag and then 3 children tags: form login, HTTP basic, and logout. And as you can kind of guess from the name, this enables functions related to authentication using username and password, and it enables support for HTTP basic authentication, which we covered in the previous lesson, and it enables the logout function, or in other words, we no longer need to write our own logout controller. One of the things Spring Security provides is a automatically generated login form that looks like this. Notice that the login URL is login, and just like in form-based security we discussed last time, this URL is handled by Spring Security, not by application code. So we don't have to write our own login controller. And note that the request parameter names are username and password, and this is the default used by the Spring login authentication controller. And there's also a hidden form field called _CSRF, and the value of the field is a random number generated by Spring Security. This field is used to protect against cross-site request forgery attack. Due to time constraint, we don't have time to get into that. Please check out the documentation if you are interested in knowing more about this attack. And oftentimes you may want to provide your own login page instead of using the default one, because the default one doesn't look very good, and it doesn't have the look and feel as the rest of your websites and so on. Again, check out the documentation and see how you can customize your login form. In particular, you can provide your own login page, and you can also provide a page where when login fails, so you can, for example, create a page that says please enter your user and password again, or reset password, contact the administrator, and so on. So check out CSNS for an example of a customized login page. To log out, we can use the URL logout, And again, this URL is handled by Spring Security, so we don't have to create our own logout controller. The newer versions of Spring Security requires that the logout request must be a post request with a _CSRF parameter. And again, this is to protect against the CSRF attacks. So to log out, we typically need to create a form that looks like this, and so that we can send a post request with an additional parameter _CSRF. The variable CSRF.token here is set by Spring Security, so we don't need to worry about what value it is. Later on, I'm going to add security to the user management part of my project. So I'm going to create this logout. So I'm going to put this logout form somewhere here. Okay, so this should create a logout button. Let me change the double quotes. Well, there are lots of double quotes there. Value. Okay, so yeah, now it looks reasonable. And just like logging, you can customize logout. Let's take a quick look at the documentation. So as you can see, you can specify a number of attributes, additional attributes for logout. And in particular, you'll probably want to set logout success URL attribute here. And by default, after logging out, it will redirect the user to this URL, login ?logout. And later on, in our case, we probably would want to change this to the root path of the application or the front page of the application. We'll do that later. Okay, so this is about login and logout, and generally speaking, we don't have to write any code, but we do need to be aware of the defaults in terms of URL, in terms of the parameter names, and so on. So login, logout can be handled by Spring Security correctly. Okay, now by adding this one line, now we have a login form and some supporting functions. But how is authentication actually done? In particular, how does Spring Security go into our database and check the username and password? Well, this is the overall structure of the authentication module in Spring Security. First, each application must have an authentication manager. An authentication manager manages one or more authentication providers. And each authentication provider handles a certain type of authentication source. For example, JDBC authentication provider would authenticate against a database. LDAP authentication provider would authenticate against LDAP directory. And pre-authenticated authentication provider works with servlet containers like Tomcat and so on. And when there are multiple authentication providers in an application, they can be configured to vote for authentication. For example, you can configure them so that a user is authenticated if there is at least one provider that can authenticate the user, or you can configure them so that it requires a majority of the providers to authenticate the user. In other words, you can ask the authentication providers to vote and take a majority vote to decide. Out of the box, Spring Security supports all these authentication sources, from database to LDAP to application servers to single sign-on technologies like CAS and OpenID. And of course, if your authentication source is not on the list, you can always write your own authentication provider. Authenticating against a database is fairly straightforward. We just need to add something like this to application context. So let's add that. So note that this is an authentication manager and authentication provider, and something called a JDBC user service. The default authentication provider is DAO authentication provider. So this tag basically says that we are going to authenticate using a database. A DAO authentication provider requires a user service bin that handles the actual database access. So this is what this one does. Spring Security provides a user service bin implementation called the JDBC user service. So this tag essentially adds that JDBC user service provided by Spring Security. And if you look at this, you can see that this JDBC user service bin requires a data source attribute, which is this one. And this means that Spring Security knows about the database URL, the username, password, and so on. So Spring Security knows where the database is. Now the problem is that how does Spring Security know which table to use or which columns to select? Well, the answer is that Spring Security will look for a couple of tables by default. In particular, Spring Security will look for a table called users with at least these three columns: username, password enabled. By the way, when the type says string, it means that it can be any string type like varchar or char or something. It doesn't have to be one specific SQL type, as long as it's something that can be converted into a string. That's okay. So, yes, what I said was we need to have a table called users, and this table need to have at least these three columns. And note that I said at least, meaning that the table can have more columns, but for authentication purpose, Spring Security will only use these three columns. You can have other columns if you want, and that's perfectly fine. The database should also have a second table called authorities, which contains the rows of the users referenced by username. And notice that these two tables are connected by username. There's no user ID here. If your database happens to have two tables exactly like this, then great, you are pretty much done with authentication. And that's pretty much the case for us, because when I design my database, I specifically design it in a way that it looks like the default schema of Spring Security. So if we already have these two tables that looks pretty much like this, then we're pretty much done in terms of authentication. So Spring Security and the default implementation of JDBC user service will take care of everything. Well, however, it's quite possible that your database schema doesn't exactly match this default one. For example, what if instead of username, you use user ID here as the foreign key column in the authorities table? Right? This is probably what you did in your homework. Well, in that case, we can customize the configuration a little bit. The JDBC user service tag has two attributes. One is called users by username query, and the other one is authorities by username query. And you can use these two attributes to customize the queries used to load the user from the database. And for the authentication provider tag, you can also add a password encoder, as we discussed in the previous lesson. And also you can provide your own user service implementation, which essentially replaces the JDBC user service bin, so that you have more control of how to authenticate the user and store the principal and so on. And we'll talk about this in a moment. Now, let's look at an example of customizing JDBC user service. And this is suppose this is my user model class, and again, it's probably something looks like what you used in your homework. If we take this class and map it to a database, we'll end up with two tables, and the first table we'll call it users, has ID, username, password enabled, and also a field or a column called email. And the second table we'll call it authorities, and we are using ID here, so the foreign key column in the authorities table is user ID instead of username. If you compare these two tables with these two tables, you can see that for the users table, we have an actual column email, and for the authority table, we use user ID instead of username. If we look at the documentation of JDBC user service, we can see that it uses several queries to load data from the database. There's a query called authorities by username query, which looks like this. There's a query called group authorities by username query, which looks like this. And then there's also a query called users by username query that looks like this. We don't use group authorities, so this query has nothing to do with us. If we look at users by username query, which is this one, we can see that this query will work just fine with our database table here. And the reason for that is, instead of saying select star, it specifically says select username, password, and enabled. In other words, no matter how many additional columns in the table, this query will always work as long as you have the three columns. And so this query is okay. It will work with our tables here. Now, if we look at this authorities by username query, however, we can see that it tries to select from authorities directly using username. And in our table, authorities table, we don't have a username column, right? because we are using user ID as a foreign key column. So what we'll do is to essentially use a different query to replace this default one, and that new query will look like this. We are going to join users and the authorities table, and then we'll say matching user ID and the username is whatever username is provided. And this query will set it to the JDBC user service tag through the authorities by username query attribute. So we'll place this one here, and the whole thing will look something like this. And this will replace the default query, and it will now work with the schema that is our design. Okay, so basically once we've done this, we added authentication to our project, and notice that we don't even have to write any code, which is great. But the problem now is that what if we want to find out which user is currently logged in? Right? For example, it's quite often that we want to use the ID or the username of the current user to determine, for example, who is applying for a job, or display a message that says welcome username to my website or something like that. But the problem here is that because authentication is done by Spring Security, we don't have access to the authenticated user like we usually do when we write the authentication code ourselves. Well, of course, Spring Security has already thought about this and provided a way to get that information about the current user. And this is how we can get the information about the authenticated user from Spring Security. You can just do something like security context holder .get context .get authentication .get principal. Example of this you can find in the CSS2 project. Let's quickly take a look. It's under web security or just security? Just security. It's something like this: security context holder, get context, get authentication, get principal. So there are, by the way, this is security context holder get context is a static method, which means that you can call this anywhere in your project. So it's quite convenient, actually more convenient than accessing a user attribute in session, because you can only do that in your controllers when you have access to request and session. But this one, you can call it anywhere in your code, not just in controllers. You can call this in, for example, in your DAO code, and in your DAO code, you will be able to access the information about current user. So to understand this, there are a couple of important things in here. First is this authentication object. This object implements the authentication interface, and this object contains the information about the authenticated user, which is called the principal. Now let's go to the documentation. So the principal object implements the user details interface. And as we can see in the user details interface, this interface has a method that we can use to get the username, to get the password, to get the roles of the user, and to check whether the account is enabled, is locked or not, whether it's expired or not, and so on. Now, one thing we should notice here, however, is that we can only get this information from this interface, or in other words, the default implementation of the principal object only give us this: the username, the password, the roles, and whether the account is enabled or not. Now, the problem, however, is that if you want to get any additional information about the user, for example, if you want to get the email of the user or the first name, last name of the user, you won't be able to get those from here. Well, what if we really want this principal object to be an object of our own user class? Well, then you need to do some extra work. So if you want to replace the default principal implementation with your own user class, then you have to create a user class that also implements the user details interface, which is this interface. And then you have to create a user service implementation that will retrieve an object of this class from your database. And then in the configuration file, you need to replace JDBC user service with your own user service implementation. It sounds like a lot, but it's actually not that complicated. Again, there's an example in CSS2 that you can take a look, and let's quickly take a look. So the first thing is our own user class needs to implement the user details interface, and it's something like this. Now notice that there are not that many methods in this interface, and things like get user, get password is enabled. You probably already have in your user class anyway, and you can return simply return true for this method: is account non-expired, is account non-locked, and so on. If you don't want to implement any specific mechanism for expiring an account or locking an account. And the only thing that you probably need to do a little bit more work is this get authorities method, because you probably need to convert string rows into Spring Security authorities, but it's not difficult to do. So all you need to do is go through the rows, which are strings, and then convert them into Spring granted authority type and return them. So all in all, it's pretty easy to create a user class that implements the user details interface. And then you need to create your own user service that replaces the default JDBC user service. And again, it's not difficult to do. So this is my implementation. As you can see, it only takes a few lines, and this user service implementation needs to implement the user details service, interface, and there's only one method in that interface, which is called load user by username, and we can create a DOM method that loads the user by the username, and if the user doesn't exist, we throw an exception that says username not found, and that's pretty much it. And the last step is to replace the default JDBC user service with our own. And the default looks like this inside the authentication provider. That's a JDBC user service. But if we want to use our own, where is that? Yeah. If we want to use our own, notice that we no longer say JDBC user service. We say user service reference and referencing our own user service. So that's pretty much it. By and large, it's fairly easy to implement as long as you know how to go about doing it. So that is for how to implement your own principal object. Now, now that we know how to do authentication with Spring Security, let's move on to authorization. We'll use a few examples to show how to do URL, method, and object access control, as well as using the Spring Security tag library for view security. Let's say that first we want to make sure that only users who have already logged in can access the user management functions. User management functions, if you remember, is the functions to view a user, add a new user, edit a user, and so on. Because we have mapped all the user management functions to URLs like /user/list or /user /add.html and so on, we can implement this security requirement by using URL-based access control. In particular, we'll require that only users who have logged in can access URLs that start with /user/. We'll need to change the HTML tag to something that looks like this. And let's first do that. And that means we need to add something called use expression to true. And we need to add a child element that says intercept URL. And the pattern is /user/**, and the access is authenticated. Okay. Something like this. Yeah. There are two things here need to be explained. First is the URL pattern here, and second is the expression here. So first about that URL pattern. By default, Spring Security uses URL patterns that look like this, which are known as the ant path pattern, because it's first used by the Java build tool ant. In this pattern, we can of course write out the exact path like this. We can also use two wildcard patterns, a single star or double star. A single star matches anything at the current level, and a double star matches anything at the current level as well as anything in any of the levels below. For example, here user slash star would match match this one, but it will not match this one because single star only matches something at the current level, and this one on the other hand will match this, will match this, will match this, and of course it will match something like this. So a double star will match anything start with that prefix, and no matter how many levels we have. And this one has two single stars, so it will match something like user A b.html, but it will not match a bc.html. Again, the single star matches a single level, and this one of course will match anything that ends with .html. One important thing to remember here is that pattern matching is case insensitive, meaning that, for example, capital case user capital case user /a would still match to this, because before matching, Spring Security will convert all the URLs to lowercase to perform the matching. So now we understand the URL pattern. What about expression? Well, Spring actually has its own expression language called Spring Expression Language, or SPEL. It's quite similar to a JSP expression language, so we are not going to spend too much time on it. We do need to know a few security-related methods and properties. The most important thing about these methods and properties is that they are all Boolean, meaning that they return either true or false. Access is granted when they return true, and access is denied when they return false. So has IP address can be used to check whether the request comes from a certain IP address or certain IP address range. Has role will check whether the current user has a certain role, and has any role will have a list of roles, and it will check if current user has any one of those roles. Permit all is equivalent to true, which means access is always granted. Deny all is basically false, meaning all access is denied. Anonymous checks if the user has logged in. If the user hasn't logged in, anonymous would return true. And authenticated is the opposite of anonymous. It checks whether the user has already logged in, and it will return true if the user has already logged in. And also in security, we usually call users who have already logged in authenticated users, and users who haven't logged in anonymous users. So later on I may use this terminology where I say authenticated users or anonymous users. Know what I mean. And remember me would return true if the user is authenticated through the remember me service, and fully authenticated would return true if the user is authenticated through actual check of username password instead of being authenticated through the remember me service. So now that we know this, and we can then understand what this one means. This one basically says if a user tries to access any URL starts with /user/, then they have to log in first. Now let's run this project and see if it works. Why so slow? Okay, so we can click File Upload. We can access this because our security constraint does not prevent access to that. But if we click User Management, by the way, if you look at the lower left corner of Eclipse, it shows a URL when I mouse over this URL, and notice that it shows /user/list.html. And if I click on that, I am automatically redirected to this login page, because to access that URL, the user must need to log in first. And notice that this is a login page automatically created by Spring Security. We didn't write any code to create this page. And if you do a view source, you can see this is what the page looks like. And I have, I believe, 2 users in my database. Okay, I have CY Sun ABCD and admin 1, 2, 3, 4. So let's log in as ABCD. And now I can access this list user page. And if I click logout, we have to change the logout URL. So the logout, notice that if I say /logout, that means it's relative to the host root rather than the application root. So that it should be something like cs jobs/logout. So the good way to handle this is to use CURL, and CURL will convert this relative path to root to relative to application. Yes. So go back, refresh, and if we do a view source here, we can see that the CURL transform that URL by adding the application context URL application context path to here. So if we click on logout, now it logs us out. Remember that we talked about customizing logout. Where is it? Yeah. So by default, after logging out, the user is redirected to the login page, and I want to change that to redirect to the root path of the application, on the front page of the application. So we can use an attribute called logout success URL for that, and let's try that. Let me stop it here. And so if you want to customize something, just write it explicitly in here. So it's going to be security logout, and this thing is called the logout success URL, and we'll set this one to / meaning the root path of the application. Let's run this again. Okay, CI sum ABCD, logout. Okay, good. So this is how we do where are we? Yeah, here. So this is how we do URL-based authorization or access control. We just need to specify something called intercept URL, specify URL pattern, and then specify the security constraint, and that's it. Pretty easy to do. Now let's add another security constraint. Let's say that we only allow a user to edit their own account, because currently, if I log in as CUI-sum, I can edit the admin user and let's say changes to 1, 2, 3, 4, 5, and that's obviously not something we want users to do. We want users to only be able to edit their own account. Also note that this security constraint is not we cannot enforce this constraint using URL security, because whether it's editing your own account or editing somebody else's account, it's exactly the same URL. The only difference is the request parameter. So here we need to do something else. Now, to enforce that security constraint, will use method security instead, and in particular, we will secure the invocation of this save user method, and so that only when a user try to save a user object, we check whether that user object represents the same user who is currently logged in. To do that, first we'll need to enable a couple of security annotations called pre-authorize and post-authorize, and we do that by adding this tag in application context. And this tag, of course, is also in the security namespace. And let's also change the codes. Okay. So this enables a couple of annotations. One is called pre-authorize and one is called post-authorize. The pre-authorize annotation takes a Boolean Spring expression, and if the expression evaluates to true, it allows the method invocation, and if the expression evaluates to false, it throws an access denied exception. And now we need to learn a few more security-related expressions. Authentication and principal are the authentication and principal object we discussed before. Method parameters can be used in an expression as a punt, and then the parameter name, and the return value of the method is return object. So now we can add a pre-authorized annotation to the save user method that looks like this. And the method is here. So if we read this expression, we can see what it means. It means get the principal object and get the user property of that object, and check if it's the same as the user property of this user parameter, right? Pound parameter name, and represent this parameter of the method. So only when these two usernames match, it will return true, and the pre-authorize will let the method invocation to proceed. If it's false, then it will throw an exception. And let's see if it is indeed the case. So I'm probably still logged in as CYSOund. So let's log out and log in as CYSOund ABCD, and I can edit CYSOund account ABCD, let's say E, and it shows E. And if I edit another user's account, we have a exception. The reason it's showing an error happened is because, if you remember, we added an exception resolver last time. So let me stop this, and yeah, this is the exception resolver, which will catch any exception and shows the error page. So let's remove this so that we see exactly what exception we have caused. So let's run this again. Okay, refresh. I'm still logged in as CYSOund, and I can change CYSOund's account, no problem. If I change admin account, now it says access denied. Okay. So we know that this security constraint worked. So when it comes to writing security constraint expressions, you can specify fairly complicated constraints using Spring expression language fairly easily. For example, if we want to say that for regular users, they can only change their own account, but for admin users, they can change anybody's account. We can add something like this. We can say has row admin or principal username is the method parameter username. So what this means is that either this one is true or this one is true, and that would be enough. In other words, for an admin user would be able to change anybody's account. And let's try again. Well, okay. So let's wait until the server reloads. Okay, go back, refresh, and I'm currently user CYSOund. Change admin password, access denied, log out, log in as admin. 1, 2, 3, 4, 5, and admin can change admin account, and admin can change CYSOund's account. So So again, it works, and you can try specifying more complex security constraints. It's by and large not difficult to do. As you can see, the syntax of the expression language is fairly concise. Now, let's add another security constraint, which says that a user can only view their own account. And what that means is, for example, if I log in as okay, so it's ABCDE now. If I log in, I can see my account, and I can see another user's account, and generally that's not good. So we want to add a security constraint that prevents that. Again, notice that the URL pattern is pretty much the same. So again, this is not something that can be easily implemented using URL security. So what we'll do is we'll implement this security measure by checking the return value of user.getUser. And as you probably have guessed, we'll use this post-authorize annotation to do that. And because we are checking the return value, which happens after the method is executed, this is where post-authorize comes in as opposed to pre-authorize. So let's grab this and put it under get user. So this one is similar to this one. Basically says the current user's username needs to match the username of the return value of this method. And again, similar to this, we can add additional rule for admin users and saying if the user has admin role, then it can do basically anything, and otherwise they can only see their own account. So let's wait a little bit. Okay, and let's try again. Let me log out first. First, I log in as CYSON, ABCDE. Yes, and I can see my account, no problem. I try to see another account, access denied. And as you can see, the good thing about specifying security constraint at a lower level is that you can change URL patterns, or you can use the same method in different controllers, and all of those different URL patterns and all of those controllers will get the same security constraint, so you don't have to specify it in many different places. So that's good. And very quickly, let me log in as admin 1, 2, 3, 4. Okay. And admin can see CYSON's account, admin can see its own account, and so on. So this still works. The last thing we'll do is to change the view a little bit. In particular, we want to hide the operations from a user if the user is not allowed to perform those operations. For example, if I log in as user CYSON, I shouldn't be able to see the links to view or edit other users. And this is good UI design because it makes it very clear what a user can or cannot do. To hide certain elements in JSP, we'll use the Spring Security Tag library, which looks like this. There are several tags in this tag library, but there's only one that's really useful, and that's the authorized tag. This tag has an access attribute which again takes a Boolean Spring expression. If the expression evaluates to true, the content inside the tag is displayed. If the expression evaluates to false, the content is not displayed. You can basically think of this as a special C if tag. The difference is that this tag has access to security-related Spring expression methods and properties, just like what we did in the pre-authorized and post-authorized annotations. And this is how we can do this. First, let's include the tag library in our JSP, and the JSP we need to change in this list.jsp, and then we'll grab this one and put it to here. And then let's close the tag. Unknown. Okay, it should be security. Now, if you look at this expression, it's pretty much the same as what we did in the annotations, except that here we say principal name is user.username, because in the JSP the user is a request scope object. So let's try this. We go to user management and we say ABCD, or we say ABCDE. Right. So notice that all the operations for viewing or editing admin account is hidden now. And if we log in at the admin user, that's 1, 2, 3, 4, and the admin user sees all the links for all the applications, because admin user can perform those operations. So this concludes our discussion about security. We prefer declarative security over programmatic security because it's easier to use and maintain. But the declarative security provided by application servers is limited in terms of functionality. Spring Security gives us the best of both worlds, as it's a declarative security framework, but also allows us to program security constraints when necessary. And when we do, it allows us to separate security code from regular application code. It's very flexible and powerful, and works on all application servers.